Hi there. This is the sixth of the Patch a Day series. I'm going to make something that reverses audio as it comes in. It obviously has to do that on some kind of windowed basis. So I don't know. You think about it, you can't really reverse something that's happening without some kind of delay. So yeah, we need a delay. I guess I'm going to start off with an easy ADC and an easy DAC, just because these are what I'm going to use. And in between the Easy DAC and the Easy ADC and the Easy DAC, I'm going to use a tap in object for a delay line. Let's give that 20,000 as an argument, which will give us a 20-second delay time. And we can put these together with a tap out, and all is groovy. And then hook these up together. We don't really need to turn this on to see what it does. We all know what the delay line is. It'll just have a 20-second delay. What we're going to want to do is to change this delay time over time, so have that dynamically changing. And the reason for that is, like, we can do all sorts of pitch effects. We can make pitch shifters. And we can also do this reversing effect, which is what this patch is all about. All right, so to drive this change, I'm going to use a phaser. Don't need any arguments in that right now. And to make that phaser so it changes the delay time, we're going to want to multiply it, because a delay time of 0 to 1 is not really going to be very useful. So we're going to multiply it by something, and that something is going to happen through a line tilde. Well, we might as well make it happen through a line tilde so we can change the effect over time. Let's say a line tilde with, let's make it change over 5 seconds. And no, sorry. Oh yeah. I'm just being stupid. Yeah, line tilde with an argument 5,000 means that its initial value is 5,000. Okay, yeah, get it straight, Barry. All right, and if we just hook these things up together, actually that's not right. I'm going to want to put a reciprocal divide by in here, so that my phaser period is the frequency, sorry, of the phaser is some kind of reciprocal of this, which is the period of the delay line that we're reading through. So let's say divide by, reciprocal divide by, which is an exclamation mark, divide by, and this is a signal, so we'll put a signal in there, a tilde in there. So we have the exclamation mark divide by tilde, which means that the signal coming in here, 10 is going to be divided by whatever the value is in the signal in the left. Okay, zoom out. All right, so let's just check that in there, that in there. I think we're going to want a float box, so F for float, and hook that up to that side of that guy right there. So we can see what happens when we change that. All right, so let's just turn this on right now and see what's going on. This might not be happening to you. Alright, so now what do we got going on? This is a bit more like what I would imagine. This is more like it. So now we just like pitch shifting down. And the higher we make this number, the lower the pitch goes. And if we get down to about, like 500, there's a certain point at which we're reading through the delay line so slowly that it drops down to about a 0 frequency, and that actually happens at 1,000 when we take the 1,000 as the reciprocal of this delay time, or the length that we're reading of the delay line. And then an interesting thing happens once we get this thing going up above 1,000 is that we get this low pitch, but then we get this low pitch in reverse. And then there's a magic number, which is 2,000, which I'm sure makes sense to you if you at all mathematically minded, which I'm not. There's a point at 2,000 at which this delay time gets back up to its original pitch. Clear this out. I've got the feedback issues with my microphone. So here we have this thing, and now it's going in reverse. I use this effect a lot, and I use it with this. Again, this is an issue. So I use it a lot, and I use it with this changing this time of the delay line, or the length of the delay line, to create really what I think are interesting effects. I mean, you can judge for yourself. So I'll start it at 5,000 and see what happens when we change it over time. Okay, that's just silly. Okay, so we can change this delay time, the length of the delay line, and you know, you might even want to base this on the. I've done this a lot, where you base this on the tempo of the tune that you're working on. So you get like one bar of reverse for every 1 bar of input, and that's about enough of the reverser action. I'll see you on the next tutorial. Patch a day.